After a successful exploitation, any attacker desires to control the compromised host. Command and control channels are a mechanism for the attacker to maintain access. To bypass perimeter defenses, C2 channels are established from inside the network outbound to infrastructure controlled by the attacker. Detection can rely on similar techniques to identifying malicious domains with a few particularities. Connections will be much more frequent and for longer periods of time, which can blend into normal traffic. Command and control over HTTP or HTTPS has some advantages for the attacker, as it's a trusted communication channel that can also benefit from using encryption. To bypass web proxies and content filtering solutions that are able to block or sync all URLs and domains, attackers can also abuse standard protocols such as DNS or ICMP. More advanced attacks leverage trusted platforms. It's very hard to detect malicious traffic going to Gmail, GitHub, or Twitter. It's even harder to block them if your organization makes use of these services. In these scenarios, the events have to be correlated with suspicious endpoint events during the same time frame. Reverse shells and remote access tools will periodically contact the adversary command and control infrastructure. This is also known as beaconing. From an investigation perspective, request and response length might be similar in size for a large number of connections. This is where the malware is beaconing, but the attacker does not issue any commands. The time intervals between the beacons is also similar. To note here that modern techniques introduce jitter, randomizing the time intervals between the beacons. Normal traffic does not follow a pattern, and it depends on how much data the user will consume and send across the network. Beacons, on the other hand, have similar size between multiple beacons, and so is the period of time between them. Jitter, as previously mentioned, will introduce some randomness to ensure that beacons are not sent at a regular period. Now is time for the practical and fun part. In this demo, we will attempt to detect Metasploit traffic, beaconing, and listening for commands. In the network section of the Elastic SIEM, we'll go again to the top DNS domain section, and we'll assume that attackers are using GlobalMantic's domain as a C2 communication channel. Dragging the domain into a timeline will reveal the IP address of the attacker machine. We'll continue in the Discover section. We'll add in a filter for the IP address of the attacker machine, and we can see when the bulk of the activity has occurred. If we look at the most common ports, we see 53 and 8000. We'll remove 53 for now. One of the odd ports is 4444, so we'll use this as a filter. Next, we'll zoom into the traffic, and we can observe a pattern similar to the one described earlier. Adding the timestamp to the field, we can see that there is a similar time interval between multiple events. If we look at the other ports, we don't see the same pattern. Some additional information on this. There are specific tools for detecting these types of patterns based on machine learning or other behavioral analysis algorithms. Manual analysis will also provide great value when paired with endpoint analysis. Having covered generic C2 traffic, it's time to explore how attackers use other protocols to establish command and control channels.